Okay, so we have learned Kirchhoff current law and Kirchhoff voltage law. Okay, so today we learn techniques to solve any network. So the first technique, two techniques, we have nodal analysis and we have a mesh analysis. So I'm discussing today nodal analysis. Okay. So nodal analysis technique is basically what we do. We try to calculate voltages of the node. Okay, for example, we have a circuit and we have say two nodes. Okay, so say what we'll do, we'll try to find the voltages of node. Okay, suppose this voltage is v1 and this voltage is v2, and if I want to find the current, okay, so I immediately, if I know the voltages of node, I can calculate the current. So if I want current in this case, I can write v1 minus v2 by r. Okay, so similarly, if the voltages here are v1 and v2, or say v1 and v2, and if I want to find the current in this direction, okay, so I can simply write v2 minus v1 upon r. So basically what is this technique? Okay, in this technique, what is the main thing? What is the main thing? We will find node voltages. Okay, so find node voltages.
Okay. Please repeat starting, sir.
Yeah, so we are discussing today nodal analysis technique. Okay, so the main points or the main procedure what we are going to follow in nodal analysis, we'll calculate the node voltages. So first thing, we'll find node voltages. Okay, once I know the node voltages, for example, these two nodes have potential v1 and v2, I can immediately find branch currents. Okay, so the main aim of network analysis is to solve the circuit for voltages and current. So if I know the voltages of node, immediately I know the voltage drop in any branch and what is the current flowing in that branch. Okay, so in order to understand this thing, okay, let me first formulate or write the steps of nodal analysis. Very elegant technique. Okay, this technique is very nice. Okay, you can immediately solve any complicated circuit also with this technique. So very useful technique to solve circuits. Okay, so let me first write the steps. What the steps you need to follow? Okay. Okay, so number one step is you have to identify nodes. Of course, you have to identify nodes. Okay, once you have identified nodes, okay, so assume there are n nodes. Suppose there are n nodes. Okay, then the number two step, okay, you will take one node out of this n node. You will take one node as a reference node. Okay, so take one node as a reference node. Then you have to apply KCL. Okay, so basically your node analysis. Okay, node analysis technique is what? Node analysis is equal to KCL plus Ohm's law. So you have to apply KCL at node, and along with you have to use Ohm's law and write the equations. So identify node, take one node as a reference node. Okay, number three is apply KCL Okay, at each node apply KCL at each node except reference node. Okay, except reference node. Okay, so when you write KCL at each node, okay, you will be getting n-1 equation. Okay, n- equation का मतलब है कि यहाँ पर जितने भी unknown nodes हैं, okay, some nodes you will be having the knowledge what is the voltage at that node, and some there will be unknown voltages. So you write the KCL equation for each unknown node, okay, and solve whatever equation you will get. Solve, okay, simultaneous equation. Solve simultaneous equations, okay, and calculate node voltages and calculate node voltages. And once you know the node voltages, you calculate branch currents. So let me explain this by a circuit. Okay, so node analysis basically KCL and Ohm's law. Okay, so will I erase this one? Okay, so let us take a circuit. So we have a resistance of 4 ohm. Okay, here we have resistance of 2 ohm, and here we have a resistance of say 1 ohm. Okay, here we have a battery. So this is my 7-volt battery, and this is 28 volts. So this plus, this is minus, this is plus minus. Okay, now first step is, what is the first step? What is the first step?
Identify nodes. Find nodes.
Identify nodes. Okay, so we need to
Find
find
nodal voltage.
Sir,
so this is a, yes, this is node. Yes, tell me.
sir, आपने voltages कितना रखा है? 20 volt.
28 and 7. Okay, 28 and 7. So first you need to identify nodes. So this is one node. Okay, say A, you have second node B,
4 node.
and this C, and this whole is a one node D. Okay, so now we have to choose one node as a reference node. Okay, so you can choose any node as a reference node in principle. Okay, but in generally हम क्या करेंगे, we will try to take that node as a reference node which is covering maximum number of terminals. Are you getting what I'm saying? We will take the node, okay, reference node का मतलब है the node which has a, we will assume the potential is 0. So this is a reference node. So I'm choosing this as a reference node because this is covering maximum number of terminals. So with respect to this node, I can find the voltages of any node. Okay, so you can choose in principle any node as a reference node, but try to take a node, okay, which is the bottom, but connected to the negative batteries or covering maximum number of terminals. Okay, so once I have defined this reference node, okay, now I need to find the node voltages. So obviously I need to find three node voltages because there are 3 nodes, 1, 2, 3. Now can you tell me what is the voltage here?
28.
28, because 28. So this voltage is already known. This node is already known to me, 28. Okay, what is the voltage here?
7.
This node also known. Okay, so only the unknown node is 1. So my things become very simple now. I have only one, I have to write only one equation. Okay, so let us say the voltage of this node is V. Okay, now I have identified the nodes. I have fixed the reference node. I want to calculate the node voltages. Okay, So now where you want to find voltage, you need to write the KCL in that node. Okay. Now I want to write KCL. So this is my node, and I don't know which direction current is going. Okay. So it is your choice. You can randomly choose current directions. Okay. So I am assuming all the currents are outgoing, and outgoing currents I'm taking positive. Okay. So while we were discussing KCL, I told you that it is a choice whether you want to take outgoing current as a positive or negative currents as a positive. Okay. Then nothing will happen. KCL will take care of everything. So now it is your choice. You want to take a outgoing current as a positive or outgoing current as a negative, but be consistent. Don't mix the things. Okay. So now I am taking all the currents are moving away. Now you can take all the currents incoming. You can take one current outgoing, two current incoming, or two current outgoing, one current incoming. You can choose whatever choices you have, random choice. There's no restriction. Okay. Everyone will give the same solution, because KCL will take care of everything. Okay. Now I am assuming all the currents are going away. So say this current is I1 is moving away. This current is, say this is I2 moving away, and say this current is I3 moving away. Okay. You can choose anything I1, I2, that is also free. Okay. So now I have to write I1. So what is the value of I1?
28 minus V upon 4.
V minus 28 upon 4 resistance. Okay. What is the current? Voltage difference divided by resistance is the current. Okay. So this is my I1. Similarly, if I want to write I2, what is I2?
V minus 7
Upon
by
1
1.
of, okay. So you need to take the direction in consider. Okay. If it is a minus here, then this will be minus plus. Okay. So you have to see the sign here. Now you have here V. So I3 equals to V minus
V minus 0.
0. Very good, because this is the reference node. So it has a voltage 0. Okay. Divide by 2. Okay. So this is your equation. Okay. Now apply KCL. Very simple technique. Apply KCL at unknown node. Okay. So KCL says sum of all the current should be 0. So here we have only outgoing currents. So sum of outgoing current should be 0. Okay. Now put values here. V minus 28 upon 4 plus V minus 7 upon 1 plus V upon 2 equals to 0. Okay. Now just solve the things. Okay. So when you solve the things, what you'll get? Tell me what is the values coming. So this is 4. So V minus 28 plus 4V minus 28. Okay. And plus 2V equals to 0. So 2 plus 4, 6, 7V. Okay. So I have now 7V equals to 56, and V equals to 8 volt. Okay. So this is my unknown voltage. V equals to 8 volt. Okay. Now once you know the V equals to 8 volt, you can find your currents. Suppose I want to find the current I1. So current I1 will be what? 8 minus 28 upon 4. This become what? 20 upon 4 minus 5 ampere.
Minus 5 ampere.
I2 will be your V minus 8 upon 2, 4 ampere. And I3 is your how much? So the I3 is your 4 ampere, I3. And your I2 is V
1
minus
ampere.
1 ampere. Okay. So two currents are going away. Okay. 1 ampere and 4 ampere. And I1 is minus 5 ampere this side. That means if I consider it as an incoming current, that will be 5 ampere. Okay. So if you question asked what is the direct current in this direction, okay, what is the current in this direction, that will be 5 ampere, because minus 5 is going here. So in this direction it will be 5 ampere. Okay, so this is the technique, very simple. Okay, and I told you everything will be taken care by your KCL. Okay, suppose you change this, you want to make this incoming current. Okay, so once you want to make incoming current, you just make it incoming. Okay, now this equation will change because this is incoming current. What will become? This, instead of V minus 7, this becomes 7 minus V. Okay, now say this is incoming current, again I have to put minus here because this is a, I'm taking outgoing current is a positive and incoming current is negative, so minus, again you do, again you get V minus 7. Okay, so as I told you, nothing will change if you change the direction of current. That will totally random choice whether you make incoming or outgoing. Okay, KCL will automatically take care of directions. So this is a, that's why this is a very powerful and simple technique. Okay, you can very quickly find out the unknown voltages. Okay, now if this
क्वेश्चन में दो आउटगोइंग एक इनकमिंग हो और अपन सारी को आउटगोइंग एज्यूम करके उसको नेक्स्ट में उसके साइन चेंज कर दें तो वो कंसीडर हो जाएगा ना सर?
हाँ, कंसीडर हो जाएगा ना भी, वो तो हमने 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 करंट माना इस डायरेक्शन में ये आ रहा है। अब एग्जाम में क्या पूछ रहा है उसके अकॉर्डिंग देख लो, अब एग्जाम में भी इधर ही पूछ रहा है तो हमारा सेम डायरेक्शन सेम आंसर आएगा, इधर पूछ रहा है तो उसको नेगेटिव कर देंगे और क्या।
जी
ओके, so this is a very simple and technique to solve. Okay, so let us solve one more problem. If anyone has doubt, please ask. So let me solve one more technique, one more problem based on this one. Okay. Anyone has a question? Because I'm not able to read the chat. Okay, you can switch on your make your mic on and ask the question. Okay, so say
जो assume कर रहे हैं इनकमिंग एंड आउटगोइंग, ऐसा कुछ रेस्ट्रिक्शन नहीं है ना, एक इनकमिंग एक आउटगोइंग ऐसा भी हम अज्यूम कर सकते हैं ना?
कुछ भी अज्यूम कर सकते हो, बस आपको only you to know,
कंसाइन करके
you only know should know how to apply Ohm's law. Okay, properly. So this 3 ampere source is coming, given. Okay, you have 2 ohm, you have a 1 ohm, and you have 2 ohm. Okay, now I want to find out, okay, the unknown. First I need to find out the nodes. Okay, so say this is my node. Okay, this is my node, this is my node, and this is my node. Okay, now I want to find out what is the voltage here. Already voltage I know, this is 1 volt. Okay, this node is unknown, so I say voltage B. Okay, and this node. Okay, so I don't need to solve this voltage for this node. Okay, because already the branch current is giving. The purpose of calculating this node voltage is to find the current. Now already the current is given 3 ampere. 3 ampere current is already coming here. Okay, so I already know, if I know this voltage, okay, I know this current, I know this resistance, so I know how much is the voltage drop. Okay, so remaining, so I can find out exactly what is the voltage of this point easily because I know everything. Okay, so here
So it
also,
will be 3 volt, no sir, at that point.
how 3 volt will be there?
The 3 I into
We have
R.
we have to see what is the actual voltage. Okay, this we have to find both two voltages, this voltages and drop that there. Okay,
So
yeah, mic, someone is mic on. Okay, let us first calculate, then we will discuss. So now I want to find this voltage. Okay, so say again assume the current, so I'm assuming outgoing current. Now this current is already given to me, so I no need to assume. Are you getting? No need to assume because current is giving. If you want to assume, still you can assume. So if you assume this direction, your current will be I3 will be -3 ampere. but because it's already given, so I'm saying okay, my this is my I3, which is equal to 3 ampere. If you are assuming outside, then you say I3 is minus 3 ampere. That also you're free. Okay, so say this is my I1, this is my I2, and this is my I3. Now I need to apply again. I need to choose this is a reference node because this is a connected with minus terminals. Okay, and covering most of the terminals. So this is my reference node. Okay, now let me calculate I1. So I1 will be V minus 1 upon 2. Okay, I2 will be V minus 0 upon 2, and I3 is already given 3 ampere is already given. Okay, now apply KCL. Apply KCL, okay, at node. So now if I apply KCL, what I'll get sum of current should be 0. Okay, algebraic sum of current should be 0. So I have outgoing current I'm taking positive. So I1 plus I2 is also positive outgoing. Now I3 is negative. Okay, so I am taking I3 as a negative equals to 0. Okay, so now if I write the I1 is V1 minus 2, I2 is V by 2, and I3 is 3 already given. Okay, so this will be V1 minus 1 plus V minus 6 equals to 0. So 2V equals to 7 and V equals to 3.5 volts. Okay, unknown voltage. So now you can write the current I1 will be what? V minus 3.5 minus 1 by 2. 3.5 minus 1 by 2. How much it will come? 1.25. Okay, 2.5 divided by 2. Okay, I2 will be V by 2. 3.5 divided by 2, that will be 1.75. So these are outgoing current 1.75 and 1.25. The total is 3 ampere current, and I3 is already given, that is incoming current. Okay, so outgoing current should be equal to incoming current. So that is, you can once check whether there is a mistake in the calculations. Okay, so in this way we have solved, okay, the thing. So now I know this potential V. Okay, V is 3.5. So this is 3.5. Okay, and this is what? 1 volt. Now can you tell me what is the voltage of this one?
6.5.
Okay, so say this is a VC. Okay, so you can say VC minus V, this one 3.5 divided by 1 ohm should be equal to what? 3 ampere current. Okay, so now if you want VC, that will be 3.5 plus 3, that is 6.5. So this is a very simple technique, okay, to solve the circuit. Now this I was solved for, so far only one node was unknown, so I am writing one equation. Okay, if there are 2 nodes, you have to write 2 equations. Okay, so let me solve.
Sir, I3 minus how to take?
Huh?
3, how to take a minus sign?
Which one? This one.
I1 plus I2 minus I3, how to take I minus I3?
So you have to take you have to go direction in the current. So current will always move from higher potential to lower potential. So current is moving this direction, you have to take VC minus V. Like I'm taking here V minus V na. Okay, so if you already know the current is moving direction, you already know. Well, obviously this is higher potential. Okay, VC minus V 3.33 ampere. If you take V minus VC, then you have to take minus 3 ampere. Then you assume current is this direction, and current in this direction is it's a minus 3 ampere.
Okay, sir. Thank you, sir.
Okay. Now let me solve the problem which contain 2 nodes. So before that, shall I give a homework? Okay, you please try. I will give the answer and the problem also. You have to solve this homework problem. Plus minus 32 volts. Okay, this is 4 ohm. Okay, this is a 12 ohm. Similar kind of problems. Okay, this is a 2 ampere current here. So 4 ohm, 12 ohm, 32 volts battery, 2 ampere current. Okay, so say this is VA. Okay, so VA and say this is VB. So find VA and VB. Okay. Now, shall I erase this one?
Yes, sir.
Yes, sir.
Now, let me give one circuit here. Ten ampere current is coming here. Say here one more current source is there. 5 ampere. Okay. So let us solve node voltage with this circuit by node voltages. The resistance is 2 ohm, resistance is 4 ohm, and resistance is 6 ohm. Okay. So first identify nodes. So how many nodes we have? Okay, we have this node, we have this node. Okay, and already current is given. So this node will, once you find this node, no, there is no resistance. Can you see? So this node and this node is same. This primary is same. This is single node because there is no resistance. So if I find a voltage, both are short. Okay, both are 1 point. So I have only two nodes. So say this voltage is V1 here. Say this voltage is V2. Okay. Now please solve. Now apply KCL at node 1. Apply KCL. Okay. Before I apply KCL, let me define the currents. Okay. So you can choose the current. Okay. So this current is coming. Say this is I1. Say this is I2. I'm taking this current outgoing. So this is my outgoing current. You can choose whatever you want. This is a choice. Okay. So in this node, we have total 3 currents. 1, 2, 3. Okay. In this node, how many currents will be there? How many currents are in this node?
3.
3. You see, one current is this one current is this one, and one current is going here. Okay. This is I3. Okay. Say this current is coming. This current is already coming. So this is I4. This current say is outgoing. So this will be I5. Okay. And top current, that is already I1. Okay. This current is going. So I already assume this is I1. So 4 currents are there. Okay. Now write the KVL. Okay. KCL and find, apply KCL at node 1. Okay. So node 1 we have 3 currents. 2 are outgoing, 1 is incoming. So I can write minus I1 plus I2 plus I3 equals to 0. Okay. Now what is the value of I1? Okay. I1 value is 5. I2 value is what? V1 minus, this is 0 divided by 2, and I3 will be what? V1 minus V2 divided by 4 equals to 0. Okay, and solve this equation. Okay, so if we solve this equation, this will give me was minus 20. Okay, plus 2v1 plus v1 minus v2 equals to 0. Okay, so this equation was 3v1 minus v2 equals to 20. This is my equation 1. Minus 3, so 3v1. Okay, what equation you are getting? Is it correct?
Yes.
Okay, now write for apply KCL at node 2, apply KCL, okay, at node 2. Okay, so if I apply KCL at node 2, we have a 4 currents here. Okay, so outgoing current positive, so I1 positive, I5 positive. Okay, incoming current is I4 negative, and I3 is incoming current, so I3 is negative. You can put 0. Now I1 is 5 ampere, I5 is V2 minus 0 upon 6. Okay, I4 is coming incoming, so this is minus 10 ampere, 10, and I3 is V1 minus V2, V1 minus V2 upon 4. Okay, so solve this equation. Okay, if I take 12 as LCM, so this become 60. Okay, it's become 2v2, it become minus 120. Okay, and this become 3v1 plus 3v2 equals to 0. So I have minus 3v1, okay, 5v2 equals to minus 120 plus 60 minus 60. Okay, this will come here, this will come plus 60. So this should be the equation. Okay, minus 3v1 5v2 60. Okay, now just solve this equation and tell me what is the answer is coming.
ऐड कर लेंगे सर दोनों
V2 equals to 20.
V2 हमारे यहाँ पे है
Okay, so if you write, I am writing the directly answer. V2 will be 20 volts. Okay, V2 should
And
become,
V1 40 by 3.
and V1 is 40 by 3. Yes, V1 is 40 by 3 volts. Okay. So this is your node analysis. Okay, I'll give couple of questions for homework also. So this is a simple technique. Okay, so I'm erasing this one.
आंसर क्या आ रहा है V2 20 और V1
40 by 3.
ओके
Now the next technique is your mesh analysis. So in mesh analysis, what we do? Okay, find mesh currents. Okay, we find mesh currents. Okay, and then once we know the mesh currents, okay, we can find the voltages across, okay, across each resistance. Each resistance means wherever it was asked, you can find. So like nodal analysis, we calculate nodal voltages. Okay, mesh analysis, we first identify mesh, okay, and assign a direction to it. Okay, assume a current flowing in the mesh and solve the simultaneous equation. Okay, whatever current, whatever each match we get the equation, that equation we need to solve. Okay, so let me explain. So let me first write the number of steps or the steps which you need to follow. Okay, So step 1 is identify the mesh. Identify the mesh, okay, and assign a direction to it. Assign a direction to it. Okay. So this is number 1 step. Okay. Assigning direction means you have to assign the direction to the current in the mesh. Okay. Now assign the polarities. Assign the polarities. Okay. So current will always move from higher potential to lower potential. So by seeing the current, you need to assign the polarities. Okay. Polarities for voltage across. Assign the polarities. Okay. For voltage across the branches. For voltages. Okay. Across the branches. Okay. Number 3 is apply KVL around mesh. Apply KVL around a mesh. Okay. Now 4 is solve simultaneous equation. Solve simultaneous equation. So shall I erase this one?
Yes, sir.
So let me illustrate this technique with a circuit diagram. Okay.
Sir,
One minute. हाँ बोलिए.
तो इस टॉपिक से डायरेक्ट क्वेश्चन आता है?
इस टॉपिक से डायरेक्ट क्वेश्चन नहीं आता है. ओके. पर एक आध क्वेश्चन आए भी है, ऐसा नहीं कि नहीं आया है. बट मेनली जो टेक्निक है ये तो बेसिक एनालिसिस है. ओके. द स्किल वी शुड हैव टू सॉल्व द सर्किट. वंस यू नो द सर्किट, ओके, वंस यू नो द टेक्निक्स, देन ओनली यू कैन सॉल्व एनी सर्किट ना. So this is a
Yes, sir.
basic skills, okay, which we should have, because finally we have to solve the circuit containing diodes and transistor. There may be capacitor, there may be inductor. Okay, so we should have some basic knowledge of these circuits. That's why I am doing this one. At least 5 to 6 classes, or whatever 6, 7 classes will go for network analysis. Okay, so that you have a confidence to solve the circuit. Okay, so you have 10 volts. Okay, 4 ohm. There are 1 or 2 problems from directly from this also. We'll solve tomorrow. Okay, 3 ohm. So this is my circuit. Okay, now how many meshes are there? 2. Okay,
2.
so you have two meshes. So first you have to assign currents. Okay, so but you have to keep in mind, if you are assigning current as a clockwise, so in second loop also you have to apply clockwise. If you are applying anti-clockwise, then you have to apply anti-clockwise. You can do one is clockwise, one is anti-clockwise. Okay, so especially take care of this one. Okay, so this current is I1, say this current is I2. Okay, now this technique, mesh analysis. Okay, mesh analysis, okay, is basically a combination of KVL plus Ohm's law. KVL plus Ohms law. Okay. Now we have two meshes. So take first mesh. Okay, and apply KVL. Okay. So if we apply KVL, okay. So first I need to apply show the polarities of voltage drops. So this voltage already known, polarity known. Here I am moving in clockwise direction. So current will always move from higher to lower potential. This is a plus minus. Similarly, this is a plus, this is a minus. If I am assuming the effective current is I1. So in this branch, I1 current is flowing, okay, from top to bottom, that is clockwise direction. I2 is moving from, okay, bottom to top, okay. So you have to take the difference of these two currents, okay. And now, so let me first apply this on KVL on this first loop. So whatever polarity I'll find, I'll write that sign, that is minus 10, okay. Then I have 4 ohm resistance, current is I1, so I will plus 4 I1, okay. Then what should I write? 6. What should I write?
I1 minus I2.
Any other? Sure, I1 minus I2 or I2 minus I1. What should I write?
Sir, minus
I1 minus I2.
Okay, because I'm assuming the effective current is this, I'm moving in this direction. Okay, so I'm taking I1, my current is this direction, I2 is opposite. So I'm writing I1 minus I2, and I'm putting plus sign here. Okay, assuming this current is positive, I1 minus I2 equals to 0. Okay, so what I'll get? 4I1 plus 6I1, 10I1. Okay, and then I have a minus 6I2 equals to 10. Okay, so this is equation 1 from mesh 1. Okay, now similarly you can choose second mesh. Okay, now second mesh I'm moving like this. Second mesh, I want to find the current. So what is the value of current in second mesh?
Minus 5 into 3.
Second mesh, I know I don't need to solve any
5 ampere.
already given 5 ampere, but I am choosing my current like this, so opposite to this one. So my I2 is what? Minus 5 ampere. Okay, so only you need to find out I1 to put the values here. Okay, so that's become 10 I1 minus 5, you put this will become minus plus you get 30 equals to 10. Okay, now if you want I1, so I1 will be what? Minus 2 ampere.
Sir, how you have find out I2 is 5 ampere directly?
So I2 is already given. Na? What is the current going here? 5 ampere. I'm telling I2 is going clockwise, it's anti-clockwise, so that is minus. I2 is minus 5 ampere. Okay. So this is a simple question. I need to solve. हाँ.
तो जिस तरह से हम लोग वोल्टेजेस के लिए इक्वेशंस बनाते हैं,
हम्म.
क्या इसके लिए बना सकते हैं? जैसे फॉर एग्जांपल I2 minus 5 into 3 plus I2 minus I1 into 6.
How?
So this जो सेकंड वाला मेश है उसके लिए जैसे हम लोगों ने पहले वाले मेश पे देख किया था, हमें वोल्टेज ड्रॉप भी तो कैलकुलेट करना है ना, तो क्या मैं ऐसे कह सकता हूँ कि I2 minus 5 into
यहाँ पर आपको यहाँ पे केवीएल लगाना है ना?
यस सर
यहाँ पोटेंशियल पता नहीं है आपको अभी तो, ठीक है. यहाँ ड्रॉप कैसे निकालोगे? यहाँ पे ड्रॉप कैसे निकालोगे? तो ऑलरेडी करंट गिवन है, तो उसका एडवांटेज लेना है हमको. ओके, सो लेट अस सॉल्व वन मोर प्रॉब्लम.
सर बस बीच वाले पे तो ड्रॉप होगा ना, वोल्टेज ड्रॉप.
हाँ,
जहाँ जंक्शन बन रहा है तीनों का वहाँ पे तो ड्रॉप.
वोल्टेज ड्रॉप हो गई ना. नाउ यू नो द वोल्ट करंट्स. ओके, so you can easily find out what is the voltage drop here, what is the voltage drop here, what is the voltage drop here. Once you know, you can find out everything. Are you getting? Okay.
Yes sir.
So
सर बट इसमें सर 15 वोल्ट आ रहा है सर.
इसमें
ये 5 into 3 15.
5 into 3 कौन सा? ये वाला? हाँ, तो आने दो.
Yes sir.
उससे क्या होता है? आने दो, जो भी आ रहा आने दो. So if you want to find it, now you have solved this one. Okay, you know the currents. Okay, so let us find out this VA, VB, and VC. Okay, so this is your homework. Once you know what is currents? Okay, you can find the potential of each. This voltage already known. This you can find. Okay, what is drop here? Remaining will come here. Okay. Similarly, what is the voltage here? Whatever drop will come, that will come here. That's way you can solve, and you can check V2 minus V1 should come upon VC minus VB, or VB minus VC divided by 3 ohm should come. VC minus VB divided by 3 should come 5 ampere. Find out VA, VB, and VC. Okay, that's your homework.
सर सर अगर जस्ट इन केस हमारा पोटेंशियल सोर्स और इसके अलावा करंट सोर्स दोनों एक साथ सीरीज में लग जाएंगे, देन हम लोग इसको कैसे कैलकुलेट करेंगे?
मतलब ये बोल रहे यहाँ पर ये है सोर्स है और साथ में वोल्टेज सोर्स भी है.
यस सर.
अब लगने तो क्या हो गया, वो फिर हम निकालेंगे फाइनल पोटेंशियल कितना है. सोर्स का पोटेंशियल पता रहेगा तो टोटल निकाल के बाकी बचा हुआ यहाँ आ जाएगा. ठीक है, अब ऐसा एज्यूम मत करो, प्रॉब्लम्स को एज्यूम मत करो, प्रॉब्लम्स आने दो. ठीक है, सो whatever actually we are doing here, okay, that is only preparation for next chapters. Okay, so that you should not find any difficulty. Once you solve them 10-15 problems, okay, then you will be confident to apply your skill on solving circuits. Okay, that is the only purpose of doing this one. And some student may be already knowing, okay, some may not be knowing, and some may be knowing how to solve the resistive circuits, but if you put inductor and capacitor, how to deal, okay, that also something we should know. And that questions also coming. It's not like that this topic they can ask question. They were last net 2020, they directly ask question based on network analysis. So every question, almost all the questions they are asking from electronics, okay, you need to apply network analysis, okay, to find the answer. हाँ बोलिए.
सेकंड मेश में इक्वेशन बना के सॉल्व किया तो भी वही आंसर आएगा ना?
जरूरत नहीं है, आप सॉल्व करो, सॉल्व करके दिखाओ आ रहा कि नहीं आ रहा. आना चाहिए. ठीक है, so now this is, let us solve one more problem. Plus minus 15 volt, you have 10 ohm, you have 10 volt battery here, you have 10 ohm here, you have 5 ohm here, okay. You have 6 ohm here, you have 4 ohm here. Okay. Find the mesh currents. Find mesh currents. So apply the current. Okay, say this is I1. Okay, say this is my I2. Okay, now what is I1? Write KVL. Okay, so apply KVL. So this will be minus 15. Okay, this will be how much? This will be plus minus plus minus. Okay, so this will, how much will come? 5 I1. Okay, and then what will get here? Here current will be I1 minus I2. So you will have 10 I1 minus I2. Okay, and then plus 10 volts equals to 0 for mesh 1. So mesh 1, what you can write now? Okay, 5 I1, 10 I1, 15 I1. Okay, and I2 is how much? Minus 10 I2 equals to how much? You have minus 15. 5. Okay, this is equation 1. You can solve it. You can say I1. Okay, 3 I1 minus 2 I2 equals to 1. Okay, and mesh 2. Now here, please carefully see. Now I am applying this on mesh. Okay, so I can start from here, or I can start here, whatever you want. Okay, so let me, here only I2 current is there, so I light this plus, this minus, because current is moving like this, plus minus. Okay, so 6I2 plus 4I2, that becomes 10I2. Okay,
minus 10 volt.
minus 10. Okay, now what should
Minus
I,
times
now what should I write?
minus times 10 I1 minus I2.
Okay, now it is your choice.
Minus I2 10.
If you want to write I1 minus I2, okay, then you take minus. Let me explain. Now earlier what you written I1 minus I2, still you want to maintain this polarity. Then what you will write? You will write
Minus times I.
plus 10. Okay, what you write? If you want to maintain, you write plus 10 I1 minus I2. Okay, now you say no, I don't want to follow this
No.
one. Okay, I want to go in the direction of this one.
Yes, sir.
So if I go in the direction this one, this will be what I currently will be I2 minus I1. Okay.
Yes, sir.
So if you're moving in this direction now, so this will be plus, this is minus. If you say I2 is greater than I1, or you want to move this direction, so what you write? You write I2 minus I1, and sign become what? Earlier it was minus here. Okay, sorry, this was, we are coming from plus to minus, so this is a plus. Now if you're moving from here to here, what you write?
So we will write minus 10 times I1 minus
I2
I2.
minus I2 minus I1.
That is same.
That is same, na? This one.
Yes, sir.
Okay, let me light again. Okay, so let me first explain first case. Okay, so first case, my current was coming here, plus minus 1. Okay, so I was writing plus 10 I1 minus I2. Okay.
Yes, sir.
Okay, now what you want to, you don't want to make this one plus minus. Okay, so what you make this plus, this minus, and this, because you make I2 minus I1. Both are same thing, na? Isn't it? Both are
Yes,
same or different?
Sir,
Hmm.
sir, before the polarity was plus minus 10 का ऊपर प्लस था नीचे माइनस था, राइट?
Yes.
तो सर हम लोग तो ऐसा भी डायरेक्ट लिख सकते हैं ना, प्लस 6I2 प्लस 4I2 माइनस 10 माइनस 10 टाइम्स I1 माइनस
If you
I2.
want to make polarity like this, plus minus 1, then you have
Yes,
to
sir.
assume the current which is coming, that is greater. Then current is I1 minus I2, not I2 minus I1. Are you getting my point?
Oh,
You can,
yes,
both are same thing. Both are the same thing.
yes, sir.
Okay.
Sir.
So if you want to take now, take minus this as a common. Okay, what am I doing any mistake?
No, sir, you're not
So
doing
it
mistake,
should be
sir.
I1
You have
minus
just taken minus sign inside.
So I2 minus I1. Okay, so either 10 minus I1 I2, or you write 10 I2 minus I1. Okay, so if you're writing 10 I2 minus I1, okay, this you add plus, and this also plus. Okay, it's correct. Okay, now solve this equation and tell me what is the answer is coming. 0.
I1 equals to 7 ampere and I2 equals to 10 ampere.
No. Again check it.
I1 equal to 1 ampere.
Yes.
दोनों 1 ampere.
Yes, I1 equals to 1 ampere.
दोनों 1 आ रहा है सर.
And I2 is equal to 1 ampere. Okay. So this is the correct answer. Okay. Please check. So yeah, you have to take care of this one. Okay, whether you want to change the polarity or not. If you don't want to change the polarity, so let it keep it plus minus 1 here. What does you decided earlier? But then current will be I2 minus I1 minus I2. Okay, if you change this one, then you current will be I2 minus I1. तो बात एक ही है, एक बार माइनस आ जाएगा, वो बात तो एक ही हो जाएगी. Okay, same thing. So
सर अगर रेजिस्टेंस 10 ohms ऊपर पॉजिटिव आया और नेगेटिव आया तो चेंज क्या होगा जरा बताएंगे फिर से. मतलब
अरे भाई चेंज
10 into I1 minus I2
अभी यहाँ पे क्या था, 10 I1 minus I2 था, 10 I1 minus I2 था ना, पहले में, और सेकंड में क्या है, I2 minus I1 है, सेकंड में I2 minus I1 है, सेकंड में साइन चेंज हुआ ना. ओके, sign is changed. Okay, both are different now. So this is how you want to apply. try to solve some questions I will give you. Okay, if you have any problems, then we will discuss again. So I'm stopping here because we cannot keep on moving, learning new techniques. Okay, in a one day.
सर इसका आंसर क्या है?
1 ampere.
सर दोनों का पोलैरिटी में चेंज क्यों नहीं हो रहा सर, जब डिफरेंट है सर?
कौन सी पोलैरिटी? तुम पोलैरिटी चेंज हो तो रहा है, कैसे नहीं चेंज हो रहा है? पोलैरिटी चेंज किया ना मैंने। ये पहले क्या था? पहले प्लस माइनस था, पहले प्लस माइनस था, तो मैंने 10 I1 माइनस I2 किया। सेकंड केस में इसको भूल जाओ, अगर भूलना है तो भूल जाओ, रखना तो रखो, तो भूलना है तो भूल जाओ। नाउ यू आर फॉलोइंग second current. Second current will be always move from higher potential lower potential. This is this one. Now you say current is moving this direction, so final current will be what? This is I2 and I1 is coming opposite, so you have to write I2 minus I1. Are you getting?
Yes sir.
If you are going from higher potential to lower potential, so you are taking current this direction, so you have I2 current in this direction and I1 is coming negative, so you assuming this is plus, so this current should be greater than this one, you have to take I2 minus I1. Okay, and if you're moving this way, you can write I1 minus I2. Okay, what this is your choice, how do you want to move? Both are same thing. Okay, so I'll send some problems, please practice. Okay, thank you very much.
Thank you sir.
Thank you, sir.
Thank you.